So let us learn Heapify technique and how to create a heap using Heapify technique. And here we have a tree with a set of numbers, and now using Heapify technique, how to create a heap is a idea over here. So let's have this array. This is our array, and with the index 1, 2, 3, 4, 5. So now what is Heapify in the sense? We were till now, how did you create a tree, a heap? We picked the first number, that is 9, and then created a node, and then we took the other number, that is 17, and then we did a comparison whether 17 is greater than 19. Yes, then you have to go ahead with swapping. So we did swapping there. Then you picked 14, and then 14 is entered. Then you're going to check whether 14 is greater than 17. No. So you go ahead with 29. When you go ahead with 29, from bottom to up, you start comparing with 29 and 9. Yes, it is greater. So you swap it. And again you will go up and check whether it is greater. Yes, it is greater. So you swap it. Then you go ahead with the next number, that is 39. So again from bottom to top. So 39 is greater. Yes, it is greater. You swap it with the parent. Then you compare 39 with 29. Yes, it is greater. So you swap it. So this is known as max heap, and this was the first method to create a heap which takes time big O of n log n. So now the idea is there is another technique which is known as Heapify technique, which helps you to reduce this time from big O of n log n to big O of n. So let's see how it is done. So now in Heapify technique, you're going to start from right to left. Okay, not from left to right. You're going to start from right to left. Got it? So in the first technique, you started with 9, then you picked 17, then you picked 14, 29 and 39, right? For the first method. Here for Heapify technique, you're going to start from 39. So let's see how you're going to start with that. So first is 39. So you pick 39 and consider this 39 as a heap, and 39 is a leaf node. Heapify is when you look at leaf node, there is no need for you to do a comparison to check whether left or right child is greater and then check whether its parent is there or not. That you can avoid. So instead, you can avoid these three nodes, the three leaf nodes, that is 39, 29 and 14. Till here you can avoid and just start working on 17 and 19. Sorry, and 9. So because 17 has two children, one is left and right. There you have to check whether it is a max heap or not. Even 9 has left child and right child, and check whether it is a heap or not, right? There is no need for you to check whether 39, 29 and 14 is a heap or not. It's of course a heap. So now that's the idea of Heapify. So Heapify is going to avoid leaf nodes and start from the non-leaf node with largest index. So now if you have here 1, 2, 3, 4, 5. Now here the largest index non-leaf node is 2. Okay, now if suppose this also had a kind of let it be this 3 and this let it be 10. So now if I'm going to ask which is the node which is a non-leaf node which has largest index, that is 3. This is the last node which has left child and right child. So now Heapify is going to start working from the last non-leaf node, okay, which has larger index. Now in this, so let me delete this. This is not needed for this example. So in this example, the largest non-leaf node is this, that is 17, which has index 2. Okay, so now what you're going to do is you are going to avoid 39, 29 and 14, and you're going to start working only from 17 and 19. So now how are we going to do? So you're going to start from 17, that is here. Okay, 17. Does it have a left child? So find who is left child. So you know how to find left child, 2 into I. and right child will be 2 into I plus 1. So what is the index of 17? That is 2. So 2 into 2 is what? 4. So now if you go to 4 and pick 27, okay, 27, and this is left child, and right child is 2 into 2 plus 1, which is equal to 5. So fifth node is 39, and compare these two, which one is greater. So whether left is greater or right is greater. Right is greater, which is 39. So what are you going to do? So you got right is 39. So see, 29 or 39? Yes, 39 is greater. So what are you going to do? You're going to check, okay, whether 39 is greater than its parent. Yes, it is. So what you have to do? You have to swap. So you have to swap here, right? Just do a swapping here. So this is going to be 17 and this is going to be 39. So this heap is done. Okay, the heap for, so here it is going to be what? 39 and here it is going to be 17. So it's updated now. Now next one, what you're going to do is, you're going to, next node is what? 9. So 17 is done. You're going backwards. So it is 9. So you're going to 9 and you're going to consider this as a whole heap. Okay. So now 9 has left child and right child. So what are you going to do? Go and find 9's left child. So here 9th index is 1. So it is going to be 1, which is equal to 2. So second node node is what? 39, and right, that is I. This is going to be 1. So 2 into 1 plus 1, it is equal to 3. So third node is 14. So let's see which one is greater, 39 or 14 is greater. So here it is 39 is greater. So pick 39 and check with its parent. So now when you check, 39 is greater than its parent, right? So now it is not a heap, so you have to make it a max heap and then swap it. So this 39 is going to come here and 9 is going to come here. So you did a swapping. Now it's not done. You did a swapping here, no? Again you have to check with this too. So it is going to work recursively, because from here you made a swap and again you have to check whether the swap has reflected here or not. So again your index is going to change. Index will be what? 2. So again you are going to see whether 2 into 2 is 4. So fourth node is 29 and here it will be 2 into 2 plus 1, 5. It is 17. So 17. So check which one is greater, 29 or 17 is greater. Yes, 29 is greater. So what you have to do, 29 is greater than its parent. So you have to swap it. So swap it each other. So this is going to be 9 and this is going to be 29. Now after swapping, check whether this has, it doesn't have, it's a leaf node. So it's going to stop here. It's going to stop here. So because Heapify is not going to touch the leaf nodes. It will always start from non-leaf node which has larger index. And it will go back to 1. Okay. This is how a Heapify technique is going to happen. So now when you look at it, but this is a normal technique and this is using Heapify. So in normal technique, what you're going to start from 9, then you pick 17, then you check whether it is greater. So swapping, if suppose you reach here, you are swapping from here till up. But whereas in Heapify technique, you are avoiding this leaf nodes and you are going to start from the non-leaf node which has larger index and going upwards. Okay, so it is from right to left you're going to work. And now one thing is, you might think, okay, when we write the code, how are we going to identify which is a non-leaf node which has largest index? So now in this case, if this is your tree, suppose this is your tree and initially your tree was like this, that is 9, then you had 17, then you were having 14, then you had 29 and 30. Suppose this was your tree. Now you want to check. So I was telling, like, let us avoid the leaf nodes, right? So we have to know from where it is going to start. See, from which index a leaf node is going to start. That is from index 3 to 5 the leaf node is going to start. So let us see. Now here what is n? 5. 5 is n. 1, 2, 3, 4, 5. 5. N is 5. So now from where your leaf node is going to start? From third index to 5. Okay. So now to check from where the leaf node is going to start, there is an equation n by 2 plus 1. That is 5 by 2 plus 1. 5 by 2 is 2.5. So you take it as 2 plus 1. That is 3. So from third index to 5 is leaf node. So you just skip till here. See, your loop will only work from 1 to 2. So how will you get this non-leaf? How will you get this non-leaf with a large index? Just your loop will work from 1 to n by 2. See, sorry, it will work from n by 2 to 1. Okay, it's ulta. It's going to work from here till backward. Okay, to n. So n by 2 is what? What is 5? 5 is n, right? 5 by 2, which is equal to 2. See, 2 will give you the non-leaf index, which has a non-leaf node which is having larger index. So from 2 to n, 2 to 1, it is going to work. So it is going to start from 2 and check whether left and right is greater or not. If it is great, which one is greater? 39. So 39 will be swapped with 70. So this is how the process is going to work. So let us see how are we going to write the code for Heapify. So next we're going to learn the algorithm for Heapify technique. So there was the same example here. Heapify, as I said, Heapify is going to ignore the leaf nodes, and it is going to start from the non-leaf node which has highest index. So now here your loop will start from n by 2 to n to 1. Sorry, n by 2 to 1. So here your n is 5, 5 by 2 to 1, that is 2. So I is equal to 2 to 1. So your loop is going to start from 2 because it is going to start from non-leaf node which has highest index. So let us start from here because we have to ignore this. The 3 leaf nodes you're going to ignore, and you're going to start from here where I is equal to 2. Okay, so let's start from I. So I'll tell you this part. There is another code for Heapify. So I'll tell you what exactly that is. So now, so your I is starting from 2. Okay, so A is the array, n is 5, n is equal to 5, and I is equal to 2. Okay, that means I is equal to 2. I is pointing here. Now we are going to take another variable known as largest. So largest is equal to I, which is equal to 2. You're going to imagine that largest is 2. Now L is for the left child. So your I is 2, right? So left child is 4, that is 29. Right child is 2 into I plus 1, which is equal to 5. Okay, so that is 5, correct, 5. Yeah, this one. Okay, so now check. There is a while loop. The first step is what? What was the first step? For this, you have to find which one is largest, whether it is 29 or 39. Okay, so we are going to check that. So L is pointing here and R is pointing here, right? L is 4 and R is 5. So you're going to check whether L is less than or equal to N. What is L? L is 4. Is 4 less than or equal to 5? Yes, it is. And also check A of L is what? A of L is 29. Okay, and A of largest, what is largest? 2. We are going to imagine that this is largest, that is 17. A of 2. Okay, is 29 greater than 17? Yes, it is. So both the conditions are satisfied. So now largest is going to be L. What is L? That is 4. Okay, now next. So you're going to think that, okay, this is, when you compare these two, this is largest. So you're going to say L is largest now. Now we're going to check this. Okay, right side. So R is what? 5. Is 5 less than or equal to 5? Yes, it is equal. And also A of R is what? 39. A of largest is what? Largest is 4. Now your largest have been updated from 2 to 4. So A of largest is 29. So 29. Is 39 greater than 29? Yes. So now you are going to update largest as 5. So largest is pointing at 5. Okay, now you got from this 2 which is largest. Now 5 is largest. Okay, now next. Check whether largest. What is largest? 5. Is it equal to 2? No, it is not equal to. Correct. It is not equal to. 5 is not equal to 2. I is 2. It is not. So now what you have to do, swap it. Swap what? Swap A of largest, that is A of 5 with A of 2. Okay, so you're going to swap, see which one is largest. 39 is largest among these two, right? So you got 39 and you're going to swap 39 over here. So you're going to swap 39 and 17. So here it is going to be 17 and here it is going to be 39. Okay, done. Got it? Now it is going to pass. Call Heapify, passing what? A, N, 5. Largest is what? 5. Okay, but when you go up and when you calculate this, it will be wrong. So now next is what? So now this will be wrong, and then sorry, it will go to Heapify, and it will be now it is going to, I is going to be 1. Okay, so now this part you will get to know more about when you're pointing at I, because it is calling recursively, it is calling itself. Okay, we'll work on it. Now I is equal to 1, right? So I is going to be 1. Imagine that largest is 1. Okay, then L is what? 2 into 1, that is equal to 2. So L is pointing, so this and all will reset. So L is pointing here. I is where? I is this. And R is also going to be 3. R is 3, right? 2 into 1 I. Let's really erase this. 2 into 1 plus 1 is 3. Okay. Now here, what is L here? L is 2. Is 2 less than or equal to 5? Yes. Now check whether A of L. 2 is less than or equal to 5. Yes, it is. Now A of L. What is A of L? L is what? 2. So A of L is 39. Okay. Now A of L is 39. Whether it is greater than A of large. Largest is 9. Yes, it is greatest. So now largest is going to be what? Largest is going to be what is that? L. L is what? 2. Okay, largest is going to be L. Now here, this next one. Next, which one is, now you're going to work on right. So right is 3. 3 is less than or equal to 5. Yes, correct. Now A of right is what? 14. A of largest is, now largest is 2, right? That is 39. Is it greater than? No. So you got that L is largest, that is 39 is largest. So it will come down and check whether what is largest? 2. 2 is largest, right? It is not equal to I. What is I? 1. Not equal to. So it is going to swap. It will swap with 39 and 9 here. So again it is 9 is going to come here, 39 is going to come here. Now this is swapped, right? Now what happened? Again it is going to work for this recursively. So again A, N is 5 and what is largest? 2. 2 goes up. So I is going to be 2. Okay, again for 2 it is going to work. See, I is pointing here 2 and L will point here and R is going to point here. See, it is going to work recursively here. Max Heap, okay. Okay, so now once this is done, so here again it is going to work. Same procedure, you check whether which one is largest. So here you will get largest as what? As 4, index 4. Okay, I is equal to 2. I is equal to 2 because you are working on this. L is equal to 4 and R is equal to 5. See, from this, while working with this 2, you will get largest as which one? You're going to get largest as 4th index. Now coming to this, is 4 not equal to 5? Yes, it is not equal to, so you have to swap it. So please do swap here. 29 goes up and 9 is going to come down. Now you have swapped and you are going to send largest, that is 4 index. 4 is going up. Okay, 4 is going to go up and then this one. L is going to be, so now I is going to be 4, right? It is not going to work. Why? Because L and R will be updated and this condition will be false. Okay, this and this is going to be false and this largest is equal to R. Okay, so now what is it? Largest is going to be, okay, so I is going to be largest, is going to be 4. L is equal to 2 into 4. 2 into 4 is what? 8. Do you have 8 here? Okay. This 9. So when it comes here, 8 less than or equal to What, 5? No, false. 9 less than equal to 5, false. False. Now here, what is largest? Largest is 4. 4. What is I? I is also 4. See? I is also 4. Is 4 not equal to 4? No. Okay. So once, so this is what this we've done. There is another, so you're going to start from here. As I said, there is a for loop for I, right? And I starts from n by 2 to 1. See, this is a for loop. And then when I, here your n is what? N is equal to 5. So 5 by 2 is what? 2. So you get the largest index which is a non-leaf node. So you're going to start from 2 to 1. Okay. So this is going to call Heapify. So initially passing 2 and then doing that particular process what we saw before. And then 1. So it is going to create a heap doing this. So this function is to create a heap. Create a heap. Got it? So this for loop and then calling heap is to create a heap. So once you create, what you have to do? You have to delete. While deleting, you get the final sorted list, right? So now the deletion happens from the root. So can you see this? You're starting from n to 1, and you're swapping with root. Root is at which part? That is what? A of 1. So you're going to swap A of 1 with the last element, as we have seen in the deletion. So now if this is if you want to delete 39, what you have to do? Pick the last element, that is swap A of n, that is the last element, 17, last element, and put it in the first location. So sorry, this is, now your array will be like this, 29, 14, this would be 9, and this would be 17. Okay, this is how your final heap sort max heap array will look like. Okay, so now the 39, if you want to delete, you delete from the root. So that is what A1 and A of n is swapping. So swap, and this you're going to store this, whatever you have deleted, you're going to store it in the 5th location. You're not going to remove it. Okay, so now that is swapped. And then what you're going to do, once swapping is done, again you have to heapify. Again you have to, rearrange. See, can you see heapify A of A, n, 1. Your I is passed as 1. So this you have to be very careful. Here it is I and here it should be 1. While creating a heap, you're going to pass I, and when you delete, and if you want to reheap it, like if you want to adjust, make sure you give here as 1, passing the argument as 1. So now again you pass 1 and again you're going to do it. You're going to rearrange the same procedure. So this is why, so now so when you're doing, you're going to again start from where? You're going to start from, see, I is pointing here, I is pointing here. Okay, so in this case, A is the array 5, 1. So 1 is passed over here. Largest is also 1, and you're going to take L and R. Which one is greater? The 29, you're going to swap with that, and again you're going to readjust. You got it? So this is for deletion. After deleting, after you swap and delete and store it in this, you get this, and you have to call Heapify again to adjust the the numbers to form a max heap. Okay, so this is the algorithm for sorting a heap, and then using Heapify technique. So when you're going to use this technique, the time complexity that it's going to take is big O of n, because you're going to ignore the leaf algorithm for heap sort for your reference, and the time complexity is big O of n. Okay.